So, today we will discuss our latest topic, work in time, which comes under the reasoning section of the mental ability section. So, this is the brand new method for solving questions based on work in time and is derived from the laws of physics, and therefore it will work in most conditions. So, let's start by discussing some of the core aspects of this new topic, work in time. Come on, excuse me. The PC is quite slow. Yeah. So basically, work done, power, and time are related by this simple formula: work done is equal to power multiplied by time. So the most important task is to define what we mean by work, power, and time. So work is something which we will define, and time is something which has not been defined yet. But here, time refers to the difference of the time between two consecutive time moments. So basically, we are talking about a time interval whenever we talk about time. And work can be regarded as anything which you are doing or someone is doing. So you don't have to really go into the physical definition of work. And power is a really interesting term, and that's pretty much like horsepower and your engine power. And that means the amount of work that you do per unit time. That's like something like output, how much output, what is your efficiency, or what your power is. So we move on to some examples to understand uh, what we mean by power. So let us assume a situation in which we build a space shuttle. So this is the shuttle which we are going to build, and it's given that 900 joules of work is to be done. To remind you, joules is a unit of work. So a guy called Jim builds it in 90 days. So what his power is would be the work done divided by the time taken. You see, you transpose the time here and you get it. So you get 900 divided by 90, that is joules per day. So his power is 9 joules per day. So it's pretty much similar to what speed is. Speed is distance per unit time, how far you go in a minute or in a second or in a day. And power is how much work do you do in a day or in an hour. So this 900 joules to make a spatial is pretty absurd. We know, often we don't know how much total work is because whenever we talk of work, it's a really abstract thing. So we don't know often that how much work you have to do if you have to bake a cake, and that may be different for different people. So actually, it's kind of a perception. So often we assume that work done is constant if the case is the same. So we can assume work to be any quantity or any variable like x, and sometimes it's useful to call it that we do, just say that we do one work. So this is the core theory behind our method. So uh, whenever you assume such a variable, at the end of the calculation, this variable will disappear and give you a true result. So its power is like an intermediate state between two different works. Let's see how. So we will have to make some assumptions while solving questions that each kind of creature or human has a unique power, and the same kind of people have the same amount of power. So these two are pretty obvious things which we do not often notice or acknowledge before solving questions, but it is important to understand, because if in any case one of the conditions is not satisfied, you will have to work out it again and using some other methods or take into consideration the changes that occur. So we move on to the approach. So just like we saw in the case of the space shuttle, say Santa does P1 joules of work in one day, so his power will be P1 joules per day. And similarly for these little creatures who do P2 joules, who have the power of P2 joules per day. That means if they work for 10 days, they will do 10 times P2 joules of work. and say if this guy has 3 joules of work, if this guy does 3 joules of works in a day, his power would be 3 joules per day. So let's assume that all three of them, or rather I would say all 7 of them, you see one Santa, 2 people and 4 the little creatures, build a yacht in some 3 days. So we assume that to build it we have to do W amount of work, W joules of work has to be done, and now the contribution of Santa will be P1 times T. Those little creatures will contribute 4 times P2 times T, and those couple of men would contribute P3 times T times 2. So the total work that must be done would be the sum of individual works, which you can see here. Now, this is again something that we did earlier, and you can review what we did. So, an architect builds a cottage in Y days. So her power would be W by Y joules. So we are here now replacing our work done by a variable because we don't really know how much work is to be done. And often this variable will get cancelled. So similarly the case of the traveler who does who does this work in X days, and his power would be W by X joules per day. So after so much discussion of the theory, let's solve a question. Now, let us solve a question. So, the question says 30 men can do a work in 16 days. How many men would do the same amount of work in 20 days? So, here are 30 people and they have to complete this one work, and let's assume that work is W. So you can give it any units that would be independent of the unit, as you will see shortly. So let's call it W joules of work. So now we assume that power of every person is P joules per day. So every man would do P joules of work per day. Now let's apply our formula. Work done is equal to power into time, and we get 30p is equal to W by 16. So 30p is the power of 30 men, which is equal to W by 16, which also represents the power of 30 men, which is work done per unit time. So now solving for W, we get W is equal to 480p. Now let's move on to the second step. So we have to find how many men would do the same work in 20 days. So we don't know the number of men, but we know how many days it takes to complete the given work. So let's assume that number of men is equal to x. So now power of x men would be equal to x times p. Now again apply the same formula, work done is equal to power into time, and this time we get the work done W is equal to power, which is x times p times 20. But from step 1 we had work done is equal to 480p, and now we can equate 20 times x times p is equal to 480p. Now pp goes off, and solving for x we will find x is equal to 24. Now, as I already said, all the assumed variables have disappeared. There is no p and no w in the answer. Therefore, w and p are independent of the unit selected. Thank you.